Let's take a look at what happens when we connect a charged metal sphere with a neutral one. And remember, with a conductor, the extra electrons collect on the surface of the object and are not tightly attached to any individual charge pair. We're going to connect these two together using a wire. We need to remember that the wire itself is a metal material, and it will have its own set of charge pairs. What happens next takes place incredibly fast, and we're going to imagine it in steps and in slow motion to help us think through the concepts that are involved. Once this wire connects together the two metal spheres, the electrons, the extra units of electrons in this sphere, have been pushing against each other, trying to get as far apart as possible. That's why they spread out on the surface of the object. And so what happens is, one of those units of electrons, let's say this one here, gets pushed off of this sphere. So let's show that like this. It's pushed over here. Now what happens next is a chain reaction. So this extra unit of electrons pushes on this one here. We have to remember that none of these electrons are tightly bound to their parent atoms, and so they move very easily. So with this new unit of electrons appearing nearby, this one gets pushed over. And the same thing happens again. This one gets pushed over, and then this one gets pushed over. This one gets pushed over, and this one gets pushed over. And so as a result, the extra unit of electrons that was located over here now ends up as a unit of electrons over here. But how far did the actual electrons travel? Well, only one step in our diagram. And in reality, this represents an incredibly small distance. If we take a look at this object, it has 5 units of electrons left, or a charge of -5, and this one has a net charge of -1. So these extra units of electrons are still pushing against each other, trying to spread out, and the push here is smaller than the push from over there. And so this process continues. This electron, that unit will push here, push that one there, push that one there, push this one here. Now we have a net charge of -2 and a net charge of -4. So the repelling effect of the electrons here is still greater than over here, and so the electrons are going to continue to push themselves along. So you get a push, you get a push, 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 push. And so let's take a look at the charge now. We have a net charge of -3 units here, and a net charge of -3 units here. And so the movement of electrons will now stop. On this side here, they will space themselves out a little bit more, because these guys are still repelling each other fairly strongly. And so they'll just even out a little bit like that. So we have 3 units spread evenly over here, 3 units spread evenly over here. So in the middle, we saw that the unit of electrons that started here has now ended up 3 steps along and is located over here. If we were able to see this actually happening, the process that we saw would take place in a fraction of a second, but it would only represent a very, very small movement, a fraction of a millimeter for any particular electron.